Assalamualaikum and hi to all. As you can see, there is a cloud of devices. But to be specific, what are there? There are a cloud of communication devices. Do you know the function of those devices? Let me tell you. Communication devices allow people to communicate with each other. But how? Communication device act as a tool or machine transmit data, instruction, and information between sending devices and receiving devices. At the end of 19th century, an understanding of electromagnetism led to the mastery of electricity. Electromagnetism field is known due to its ability to convey information over distance or through air. Most electromagnetic waves are radio wave, which is also known as radio frequency. Radio waves have a wide spectrum ranging from 10 kHz to 300 GHz. Instead of Bluetooth devices, there are many communication devices available with its own fantastic applications such as infrared device, modem, network card, smartphone, and Wi-Fi devices. Do you know the working principle and the application of those communication devices? No? Don't worry, we will help you.
Okay, firstly, we will look into the basic working principle of the communication devices. The picture shows, at one end, a transmitter encodes an information by varying amplitude or frequency of the wave. At the other end, a receiver tuned to the same wavelength will pick up the signal and decodes it back to the desired form, either sound, image, data, or other kind. Now, we will look in detail at the flow of the communication system. There are 6 key points will be discussed, which are sources, input transducer, transmitter, communication channel, receiver, and output transducer. First is the sources. It can be classified into two types, either electric or non-electric. They are actually the input signals. Example of sources are audio files, email messages, television pictures, and many more. Next, the signal will be detected by the second element, which is the input transducer. It is known as sensor and used to capture non-electric sources like sound and light. It will convert them into electrical signals. Without it, the transportation of non-electric sources over great distance will not be effective. Some examples of input transducer are microphones, cameras, keyboards, and mouse. Then, the signal will pass through an electronic circuit containing noise filter, analog to digital converter, encoder, modulator, and signal amplifier. After the amplification, the third element, which is the transmitter, will modify the converted electric signal from the source signal for an efficient transmission. At the end of the circuit, there is an antenna where the signal is released as electromagnetic wave or electromagnetic radiation.
Now let's continue with the fourth key point, which is communication channel. It can be referred as medium by which a signal travels. The transmission medium is the physical path between transmitter and receiver for data communication signal energy. There are two types of media by which electrical signals travel. The first type is guided media. It can be defined as the physical medium through which the signals are transmitted, also known as bounded media. Hence, three guided medium are twisted pair cable, where the twisted pair consists of two insulated copper wires arranged in a regular spiral pattern. This type of cabling is used for telephone communication and most modern Ethernet network. Degree of reduction in noise interference is determined by number of turns per foot. Thus, when the number of turns per foot increase, noise interference decrease. Next guided medium is coaxial cable. It commonly used in transmission media, for example TV wires. The coaxial means that it contains two conductors parallel to each other. It has a higher frequency as compared to twisted pair cable. Inner conductor made up of copper and outer conductor is made up of copper mesh. The middle core is made up of non-conductive cover that separates the inner conductor from the outer conductor. Middle core is responsible for data transferring, whereas the copper mesh prevents from the electromagnetic interference. The last one is fiber optics, a cable that holds the optical fiber coated in plastics that are used to send the data by pulses of light. The plastic coating protects the optical fiber from heat, cold, and electromagnetic interference. Fiber optics provide faster data transmission than copper wires. Meanwhile, the second type is unguided media. In unguided media, data transmit through space directed from transmitter and receiver means that it transmits without any physical medium. It can carry such electromagnetic signal as first, radio waves. Radio waves are the electromagnetic waves that are transmitted in all directions of free space. Range's frequency is from 3 kHz to 1 kHz. An example of radio waves is radio FM. Radio wave is useful for multicasting where there is one sender and many receiver. The second one is microwaves. Note that it is not only microwaves often but also satellite and radar communication. The third one is infrared. Infrared transmission is wireless technology for short ranges. Example of short ranges communication are through cell phones and TV operation. It supports high bandwidth, hence data rate will be very high. Now we continue with the receiver. Receiver or interpreter is the one which a message directed to. The receiver has to capture and reconstruct the signal before pass it through the transmitter. This is done by passing the signal through another circuit containing these components. First, noise filter. Second, demodulator. An electric circuit in software-defined radio used to recover the information content. Third one is decoder. Fourth is signal amplifier. Then the last one is digital to analog converter. Most signal will lose its energy after pass through communication channel or medium but can be boosted by passing it through signal amplifier. The last one is output transducer, also called as actuator. It do the opposite of input in transducer as it takes electrical signal and converts them into another form of energy. These transducers respond to temperature, electromagnetic radiation intensity, force, displacement, or chemical concentration. It can be perceived by one of the human senses. For example, produce sound with a speaker or buzzer, produce light with LED or lamp, produce movement with an electric motor or a solenoid. Some common pairs of input and output transducers include microphones and speakers for audio signal, keyboards and computer monitors, camera and liquid crystal displays LCD, force sensors, buttons, and lights or motor. Note that input transducers convert non-electrical signals like voice into electrical signal, while output transducers convert the electrical signal back into sound or picture or others. There are many different types of transducers and the combination are limitless.
We will go to the application of communication devices. There are 6 points we will be discussed, which are Bluetooth devices, infrared devices, Wi-Fi devices, modem, network card, and smartphone. For the Bluetooth devices, it has a short-range communication device which works on a 2.4 GHz frequency. It can only transfer data up to 25 megabytes per second. The range of the network spectra can get cut off at about 30 meters. Infrared devices is an electromagnetic spectrum extending from long wavelengths of a red end of the visible light range to microwave range. It has a range of 0.78 to 25 micrometer of near infrared, 25 to 50 micrometer of middle infrared, and 50 to 1000 micrometer of far infrared. Mostly, people use this in a thermal imaging and sensor. Wi-Fi networks have a range that is limited by the frequency, transmission power, antenna type, the location they are used in, and the environment. A typical wireless router in an indoor point-to-multipoint arrangement using 802.11n, which can be used either 2.4 GHz or 5 GHz. The stock antenna might have a range of 50 meters or less.
Now I will proceed with the next application of electromagnetic wave, which is a modem. A modem, or the full name is modulator demodulator, is a small box that connects devices to the internet using cables. Unlike a router, a modem doesn't provide home with Wi-Fi connectivity. A modem actually acts as a digital translator, taking an information signal from cable and make it accessible to computer. It sends and receives electromagnetic signal back and forth to a computer network station, or commonly called a Wi-Fi hotspot. Next is the network card. It is a computer hardware component that connects a computer to a computer network. The card translates computer data into electrical signals, then send it through the network. The signals are compatible with the network so computer can exchange information. The last application is mobile phone. Nowadays, mobile phone have become commonly used in our life. But do you know that for a mobile phone to operate sufficiently, it is necessary to be within the range of the base station of one's operators and receive a radio signal of sufficient quality. The most latest and the fastest one is the LTE, or we call it as 4G, which runs on 800 MHz, 1800 MHz, and also 2600 MHz frequency bands. Using new encoding technologies, 4G can already triple the output obtained in 3G to receive 100 Mbps and thus make uses like video calls or live TV possible while on the move. And lastly, the latest version is the 5G technology, which is designed to handle even more data and increase connectivity. It will support the Internet of Things, which connect billions of connected objects. 5G will also support tomorrow's innovation in a wide variety of fields such as healthcare, public safety, transport, agriculture, and also smart cities. 5G technology will be able to operate on both the lower frequency of the spectrum, which is below 6 GHz, and also the higher frequency known as millimeter wave, which is greater than 6 GHz.
So now we know the working principle and application of communication devices. Hope you enjoy our video and thank you for watching.